Now that we've measured some of the physical properties of these materials, let's take a look at the impact they had on flowability. Let's start first with VivaPure 101 and ProSolve SMCC 50. Now, both of these materials have median particle size around 65 microns. We also measured their bulk density, and they were pretty similar. Even if we take a look at how they look physically, their structure. So VivaPure 101 is MCC, microcrystalline cellulose, and it has this fibrous structure from the refinement of cellulose pulp. ProSolve SMCC 50 has a very similar structure on the grand scale, but is actually silicified microcrystalline cellulose. So the primary difference between these two materials is not size, it's not density, it's not even shape, it's silicification. And that is perhaps then why we saw such a difference in angle of repose when we measured it. So for MCC, a small particle size MCC, we got a poor angle of repose of 47 degrees, whereas with silicification, we got a much better angle of repose, although still in the passable range. So here, the primary difference is silicification, which can actually act to reduce the friction between particles. So as these fibers try and move past each other while they're flowing, they can kind of stick to each other more with the MCC, but with silicification, they kind of slide past each other more easily, leading to better flowability. Now we can take a look at the effect of adjusting the particle size. So here, our bulk density we measured at 0.35 grams per milliliter. From other measurements, we know that the particle size is around 125 microns for ProSolve SMCC 90. And here you can see there's a little bit of difference in the shape with the larger particle size. The fibers are in a little more blocky shape. The bulk density hasn't really changed, but we do see a big reduction in angle of repose compared to the smaller, more fibrous silicified microcrystalline cellulose. So now let's take a look at the other materials we evaluated. First, let's take a look at MCompress Premium, which is dicalcium phosphate dihydrate. And here we had a median particle size around 230 microns. So that's actually a lot bigger yet. So, you might expect a bigger flow. It's also got a higher bulk density. We measured about 0.92 grams per milliliter. So conventional wisdom would say larger particle size, higher bulk density, the angle of repose or the flowability should be better. But in fact, we only measured an angle of 36 degrees, which is at the upper end of the good range. So one possible explanation is while the overall shape is roughly spherical, there are a lot of angularities and projections that could interlock as these materials move past each other. And in fact, we know that there's a lot of friction between these materials as they flow. Whereas, as I mentioned, the ProSolve SMCC 50, the silicification lowers the friction between the particles. And so even with the advantages of density and particle size, you don't always see an increase in flowability to the same degree. Finally, our MDEX material, which is dextrates, has quite large particles, about 280 microns, a very spherical shape compared to all our other materials, where these materials can roll past each other better, and a median bulk density of around 0.65 grams per mil. And in fact, for this material, we did see a decreased angle of repose indicating better flowability of this material. If you recall, the pharmacopoeia has an additional metric that can be used to estimate flowability, the Hausner ratio. In the lab, we did approximate this in our tap density measurement, looking at bulk volume over tap volume. And for MCC, VivaPure 101, we got a value of 1.3, which is in the passable region. So if we take a look at our MCompress Premium, we measured approximately 1.11 Hausner ratio, which is borderline excellent flow. And we did see a big decrease in angle of repose, a big increase in flowability between these two materials. However, when we take a look at our ProSolve SMCC 50, where we saw a big increase in flowability, we actually estimated a Hausner ratio of exactly the same, 1.3 between the MCC and the same particle size SMCC. And this shows you that the Hausner ratio, while valid for some materials, is not always the best estimator for flowability. And so in fact, we prefer to use angle of repose most of the time. So Hausner ratio, angle of repose, at the end of the day, none of these laboratory methods really give a full picture of flowability as it relates to tableting. The true measure of flowability is, of course, the tablet press. Here you'll be able to see differences such as how the powder interacts with the material of the hopper, and also be able to adjust for flow challenges by using a paddle feeder to push material into the die. As a result, the Flodex does not limit what die size you can use, and the angle of repose can be overcome by a little bit of force.
In the next episode of JRS Tableting Studio, we explore the importance of blend homogeneity in tablet production. Using a pigmented model API, we demonstrate how insufficient mixing can impact compactability, flowability, and overall tablet uniformity and quality. JRS Tableting Studio. Stay tuned.